Hey, good to be back. I'll see you in a second. A very useful thing indeed, a robot that can follow pre-planned routes. Such robots are already being used to drive actual trains. What's more, my name, Dr. Drone, actually comes from a type of robotic unmanned aircraft that can be programmed to follow preset routes. But Eve is still going to need a little bit more freedom than this. He needs to be able to move around freely without fear of running off of desks. What he needs is walls to prevent him. Luckily, this black tape can already double as a wall. Let me show you how to do that with our next program called Stay Inside the Bubble. For this experiment, we are going to need to create a box using our black tape for Eve to move around inside. These lengths of tape will act as Eve's walls. Get your laptops ready, boys and girls. Begin by opening a new program. I'm going to call this one The Bubble. So, here we go again. Straight off, we want to start with another switch loop inside of a regular loop block, which is set to infinity, as once again Eve will need to keep continuously checking to make sure he hasn't run into any black tape. Once again, we want the switch block set to color sensor, compare, reflected light intensity. Also, we want compare type 4 again, or less than, and an intensity of 30%. So this time we are working with both of Eve's wheel motors at once, so we need a tank block. It's easier if Eve can turn on the spot for this maneuver. This top option is going to be what Eve does when he runs into some tape. And what would you do if you were to run into a wall? Step back, turn around and walk in a different direction. So that's what we're going to make Eve do. In the top half here, we're going to make him reverse and change direction. So for the first tank block, we want to do the reversing. We know how to reverse our engines from the previous episode. So let's set each wheel here to negative 20% speed and the number of rotations to 1. This will give Eve a decent space to back up before trying a new direction. Next we want the turn, so we need our second tank block. In order to turn on the spot, we will want one wheel going forwards and one wheel going backwards. So we need one wheel with positive power and the other with negative power numbers. And they must be level, or otherwise the turn will not be on the spot. So we want one box set to 30% power and the other to negative 30% power. And I'm going to make my rotations 1.89, but this turn can be as big or as little as you like. If a room has many hidden doors, you may want Eve to check all along the wall to find them. Now, in the other option, we want Eve to be walking forwards for when he's not running into walls. For this, we want a steering block, since Eve is simply moving forward. Let's set the power to 30% and making sure the boxes are set to on for rotations, you want to choose a very small fraction of a rotation. I'm going for 0.05. This will mean your Everstorm is checking the floor for tape almost constantly, as every time he moves 1/10 of a rotation, he will check the floor again to make sure he has not run into any tape. And thus your program is complete and ready to be downloaded and run.
Goodbye, foolish Victor. Oh no, 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 what is this? I am trapped.
Sorry, Eve. Can't have you running off into the big scary world just yet. I want robots running around just as much as you do, but there's a few more things that we need to do before we can get there. But look at that, that's one more hurdle overcome. Now you don't need to keep running off of desks all the time. Next thing you know, we'll have you sitting at desks, like a person, like me.
I would make a better presenter than you.
Alright, calm down, you crazy little robot, you. What's more, using the same principles with the switch block as we used in this program, there is a lot more that can be achieved. By going to the options on the switch block under Color Sensor and Compare, you will see the option labelled Colors. By selecting this, you can go to this options menu and select from a few different colours to have your color sensor react to. You could also combine multiple switch blocks in one sequence of commands, so Eve will react differently when going across different coloured surfaces. But that's something we'll come back to later. Well, Eve, if you're really so keen to go out into that big bad world of ours, you're going to need to learn how to defend yourself. There are baddies hiding everywhere, and they often hang out in dark places where even being able to see like a person can't help you. But this is just one more opportunity for you to show us how much cooler robots are than people. Because, you see, my robot friend, you do not need lights to see in dark places. You have infrared.
Infrared is a harmless form of electromagnetic radiation. It is a form of radiation that is invisible to the human eye. Infrared sensors can be used to detect heat and proximity.
Yes, that's right, proximity. How far away different objects are from each other. Eve's headpiece contains an infrared sensor and projector. Infrared is like an invisible form of light. This light can be intensified into a beam, like a real-life laser beam. But that's all that a laser beam really is light focused into a beam. Eve fires this laser beam out from his eyes, laser vision. If this beam bounces off of any object and is reflected back into Eve's eyes, Eve will then be able to tell from the intensity of the returning laser beam how far away that object is. This is like how bats or dolphins use sonar to detect objects around them, except for using light or radiation instead of sound to bounce off of objects. Another example of an infrared beam and sensor mechanism is how almost all television remote controls work, except the transmitter is on the remote and the sensor on the television, and instead of measuring proximity, the way the signal from the remote flashes is used to send messages to the television. So we now understand how an infrared sensor works. Without us being able to see it, Eve's headpiece, when activated, will begin firing out an invisible laser beam. This beam will continue to go outwards until an object is placed in its path, say this shoebox. This works best when using a flat surface. When the laser beam bounces off of the shoebox and into Eve's eyes, Eve will then be able to tell how far away the shoebox is. So Eve, using this new skill, I'm going to show you how you can spot your enemies from a distance, and then I'm going to teach you how to deal with them. So, kids at home, get your laptops ready, and we will begin. So let's begin a new project. Call this one Code Red, because we only ever want to use it in an emergency. So we start off with a switch loop, since we are using an input again. Go to the main drop-down menu on the block and you will see an option labelled Infrared Sensor. That's our baby. Go to that option and then Compare, and then that magic word Proximity. Now the other options are automatically set to option 4, which we know means less than, and 50%. So, this means that if an object passes within 40 centimeters of Eve's infrared sensor, then the actions in the top half of the block, marked with a tick, will be performed. If not, the actions in the lower half of the block, marked with an X, will be performed. Eve's sensor has a range of approximately 50 to 70 centimeters, so 40 centimeters should be well within his abilities. So when Eve does spot an enemy, there is only one thing to do: launch at him like a wall of fury. For this reason, we should put in the tick box a steering block. No actual steering, so set that to 0. Top speed at 100% and 3 rotations to make sure Eve launches himself far enough. And that's about all you need, except that if this program were to be run and Eve finds an enemy, he'll just keep running at them at full speed even after he's hit them. This isn't very good for your Everstorm's motors, so best to add this loop interrupt block, which can be found here in the flow blocks. The interrupt block keeps the loop from repeating the program, so the program will end after the first time Eve finds an enemy. So now your program is ready to run. Let's see it in effect. So before I activate the program, I'm going to just move the box out of the way here. Now I activate our Code Red program. The laser beam is now being fired out of Eve's headpiece. So, if we move Eve's enemy back in the way... Yes! Yes! Go, Eve! Kill! Destroy! Brilliant! Brilliant, Eve! That's another section over. We'll see you soon. Make sure you download our objectives.